Yeah, thank you very much. Wow, I'm amazed. You Dutch guys know how to open a conference, right? I was very impressed to see that great show. And the conference is called Advancing in Movement, kind of this translated. I don't speak Dutch, so I trust on what the people tell me. And I would like to give you the story of how we in Zurich try to advance in movement therapy. And I was also asked to bring something with me, and what I brought with me is a motor, a small motor. Number one, it's a motor that generates movement, right? So it fits, I think, to the title. It's also a motor that was driving one of the very first prototypes of the Hocoma, the robot that I will show you, amongst others. And I think it also stands for Swiss qualities, right? It's small, tiny, but it has a lot of power inside, and it's high-tech. So that's the thing I brought for you. It's small, but from Switzerland, I couldn't bring a Hocoma, so I had to bring something small. I'll put it here. And to start, I first have to tell you that I'm biased, so everything you hear is completely biased, because I am, as you heard, a founder and the CEO of Hocoma. And you also heard, I mean, Remco already gave you the summary of my talk a little bit, right? But what you also heard is that in the beginning, people were saying that we are crazy. And when was the beginning? I'll go a little bit back in history, but it is actually more or less exactly 20 years ago, when in September 20 years ago, we trained the first patient in a Hocoma prototype. And 2 months later, so in November 1999, we showed this robot at Rehabilitation, one of the biggest rehab fairs in the world. At that time, it was in Düsseldorf. And I still remember that everybody that walked up to the booth said, now they're crazy, the Swiss. They think they can build a robot that is going to train patients. And I want to tell you today a little bit of the story of why we still made it happen and what the future will also bring in this field. The vision that we have today is we want to improve millions of lives by providing functional and efficient solutions that set the standards for human movement therapy. Well, these are great words, right? What does that mean in detail? What could that mean for a single individual patient? And I would like to show a patient example here. It's a German guy, Dr. Bernd Kral. He was an entrepreneur and had huge strokes. And he got into the ICU. They told his partner that he only survived the second stroke, which followed just a few days after the first, because the skull was already open. And they said to the partner that Bernd only has a chance of surviving of about 10%. And after he had a standard rehab in Germany, not in a third world country, about 12, 13 years ago, they said, most likely for the rest of his life, Bernd Kral will stay in a nursing home. And it was Marion Schrimpf, the partner, that said, no, that's not going to happen. There is new technology, there is neuroplasticity, and my husband is a fighter. So what she did is she bought a lot of equipment, a lot from Hocoma, but also from other companies. She hired her own therapist, and she built her own rehab center to do, after the standard rehab, very intensive therapy, so that Bernd Kral would not end up in a nursing home, but learn to stand, learn to walk. And today, he's actually running the Ambulantikum, a outpatient rehab center to intensively train neurological patients that come out of standard rehab and that have the prognosis of not improving anymore, but they make these miracles, which are not miracles at all, happen. And one of the patients that trained in this Ambulantikum is Nele. Nele, you see her here on this video. Nele had a developmental problem. She was diagnosed from the doctors that she would never learn to walk, but with intensive therapy in the Ambulantikum, with help of our robots, but the robots are just a tool, they're not the miracle. Nele learned to walk, and I think it's those improvements, these things that we want to make happen and why we do what we do. So, but how did we get here, right? We didn't start with this big vision. We started in research, and I'll show you in a minute how we did that. But what we want to do with our technology is we want to significantly improve outcome, just like you have seen it in the videos right now. And this we want to do by intensify therapy, because that's the key. The key is you have to train more. We have just seen, I think, tennis players, maybe one you recognize from Switzerland, right? You're also good in playing tennis. And what is the key? Why do you think Roger Federer plays so well tennis? Very easy, because he trained a lot. So if you want to learn a functional movement, you have to train it. And what we do, we develop the tools that allow you to train much more intensely. And I will maybe be able to even show you how, even though these devices are expensive, we will still save a lot of money. Okay, so how did it all start? You heard the story. By coincidence, I got a job as the head of research in a spinal cord injury center of the University Hospital Zurich. And the research we did under this professor, famous Professor Volker Dietz, was intensive training. And in the 90s, this was done by the so-called body weight supported treadmill training. You see on the right side here how this is performed. You have a patient supported in a harness, and two therapists make this patient who can't walk yet walk. And you see these videos from 1993, and there wasn't a robot yet, so I had to do the training myself. I was the researcher on the right side doing this movement. And being an engineer, of course, I thought, well, there must be a better way than ruining two backs of two therapists to help one patient. And that's why we started to develop a robot that hopefully could do this training automatically. And that robot is called Hocoma. And I want to show you, these are very early movies, what you see here. I want to show you what the Hocoma does. So on this video, you see an incomplete spinal cord injured patient. So he's already able to stand. And you could argue that he's doing, that he's training to walk, but he's actually not. What he is doing is training to do pathological stepping, and he actually also is training to have security in his hands. And with the robot that we built, the Hocoma, it's a driven gait orthosis on a treadmill. So now you have the patient still on a treadmill, body weight supported, but now the robot is assisting the movement. And so now the patient is actually training to walk because he can do physiological stepping, he's upright, he can learn to trust in his legs rather than in his hands. And most important, he can train 1,000 or 2,000 repetitions in each training. That was the key idea, and indeed, in the first patients that we trained, and this is an example from UT Southwestern in Dallas, you see this incomplete spinal cord patients after 12 weeks regained a quite nice walking function. But we got a lot of criticism on the Hocoma in the beginning, because the therapist said, yeah, now he's doing repetitions, right? Because the robot makes the patient move 2,000 times. But intensity does not only mean repetition, because if there's passive movement, there is no functional improvement. So besides the repetition, you also need effort. The patient has to participate, and only if those two things are there together, only then will the patient improve. And so this meant we had to improve the Hocoma, which you could argue was only a machine until we started to introduce sensors and until we started to introduce also a little bit more intelligence, which we did by introducing force sensors in the first place, so we could measure the interaction between the patient and the machine. So we always knew when is the machine working and when is the patient working. And with this information, we can give what we call an augmented performance feedback, so that the patient always can see how much he is doing himself, so that we can always try to engage him to a maximum extent, and only if we achieve this, closing the loop, can we get the maximum output. That at least was the theory, but the research is showing that this theory is correct, at least in terms of the output. So this was the very first study that was done with a Hocoma and pediatric neurological patients, mainly CP and stroke. where they looked at how much was the patient participating if there was just a DVD, a movie played to these kids, and then you see there was very little activity. The patient was concentrating much more on the movie than he was on his movement. In the middle, you see how much more the patient was participating and active in the rehab when the therapist was motivating the patient and telling him to do longer steps, to be more active. But when they started the interactive gaming, so these augmented performance feedbacks are displayed in games, you see that then again more than double activity of these kids and significantly more participation. What we don't know, what we don't have yet, is the study that proves whether this has a functional improvement after the rehab, but this should be pretty obvious that the patients learn much better if they participate more. So what I showed you very quickly are the two core competencies that we developed. One is how can we mechanically, with robots, support patients to do the movements more physiological with more repetitions. That's core competence number one. And the second core competence is how can we engage the patient to be maximally active during rehabilitation with this augmented performance feedback. And with these two core competencies, we did, of course, develop other products, and I will quickly show you some of these products in a minute. But another important thing I would like to mention is intensity matters, right? But intensity is something that we should have over a long phase. You maybe saw this very first patient I showed you, no, not the very first, but the one in the Hocoma, the old video, 12 weeks of intensive training. So I think in the Netherlands you still get 12 weeks of rehabilitation, but unfortunately the inpatient duration is not being longer, it is actually being shortened all the time. And so the intensity that we apply to the patients, here you see schematically maybe what we get today on intensity, and that should be improved, right? We should get more intensity, but what you see here is also, it's not just in the inpatient phase. We need intensive training until the patient has reached the maximum of his capacity. And that's why it's also important to develop different products for the different phases of rehabilitation. And that's what we did. The second product we developed is actually for the even earlier phase. It's the Erigo, a robotic tilt table, so you can start mobilizing patients already in the acute hospital. And then the second device from the rehab continuum, but the first device we developed is, of course, the Hocoma. And we said, but after the Hocoma, we also need other devices, because the Hocoma is good for patients that are not capable to walk at all and need a lot of support. But if the patient gets better, he maybe still needs support, but he doesn't need the Hocoma anymore. So we said, what approaches are there to support a patient? There are overground systems, but the problem of the overground systems is they're limited. You can't walk further than the overground system. There's more flexible stuff like a walker, and the walker you can walk wherever you want, but again, you have the problem you're crouched and you rely on your hands. So we said, how about trying to combine those two approaches? What if we develop a system that gives you the freedom to walk wherever you want, but gives you bodyweight support from above and gives you the freedom to walk wherever you want? And that's the Andago. And the Andago now, if you see here on the left side, a patient walking classic way, and you will see right now that he almost stumbles. I mean, that's even a safety problem, right? While on the right side in the Andago, he is always safe. He has a body weight support, but he can still walk wherever he wants. He can do it with or without the handrails. And you could, of course, imagine that, like with all of our devices, it's possible that 1 or 2 or 3 patients are actually training together with supervision of only one therapist. Since 2016, we worked together with Motek, so we did a merger with DIH, our mother company, and so Motek here in the Netherlands is our sister company, and Motek has the C-mill in their program, a treadmill, instrumented treadmill with projection, so you can do balance training, you can do obstacle avoidance, you can do targeted walking, and you have augmented performance feedback, you have gamification, so a product that fits very well into our spectrum. If the patients get better, they can train a lot of different versatile walking functions in a safe environment. And if you would take all these concepts one step further, combine again different technologies, you would get to a product which is, I would argue, brand new. It was just launched more or less last year. There's only about, as far as I know, 4 or 5 installations yet, and that is the Ryzen. And the Ryzen is, again, a bodyweight support system that gives you the safety. That's always the most important, I think. But besides the safety, it gives you the possibility to give bodyweight support, possibility to adjust, to actually apply forward or sideward forces, whether that is to assist or whether it is to perturb. The Ryzen, I guess, is the most versatile system to train many, many different functions, from standing up, from walking up and down stairs, to different perturbations, to even challenge the patient. And I think that shows you how we try, for the different phases of rehabilitation, to always have the best product, and the Ryzen now fits very nicely into this track. And I learned that the St. Martin's Clinic will soon maybe be the first clinic in the Netherlands with a clinical installation of the Ryzen. Would, of course, be one more step ahead of the St. Martin's Clinic in new technology. So that's the spectrum for the lower extremity, but functional movement therapy is not only something you do with your legs, you also do it with your arms. You also have to relearn using your arm after a neurological injury. So we also worked on a product portfolio for the upper extremity. I will not have the time to go into the detail of all the products, but for patients that need a lot of support, we have the Omeo Power on the left side, a fully robotic device. That was a tech transfer development together with ETH. In the middle, the Omeo Spring, a passive system that supports your arm. And on the right side in the video, you actually saw the Omeo Boom, an early version in our portfolio, which comes out of the University of Twente. The inventor, Arno Stienen, is actually even somewhere in the audience here today. And I think what is also a strength of what we always tried at Hocoma is to not invent everything ourselves. I think you've seen already that we always try to work with good partners, whether that is Motek now as a sister company, or whether it's the different products. So one example is the Omeo Spring. The Omeo Spring is a product that was developed by Professor David Renkensmeyer from the University of California, Irvine, together with the Rehab Institute of Chicago. I saw it at the International Conference on Rehab Robotics in 2005, and that's what it looked like at the time. It was actually a quite primitive prototype with rubber bands. You had to put more rubber bands to get more support, and they had sensors so they could give augmented performance feedback. But I think it was the idea behind it, again, the mechanical support, the augmented performance feedback, that led me to negotiate a license agreement with University of California, Irvine, to bring that product into our portfolio. And today, I think it's the most successful rehab robot in the world, I think, with more than 1,000 systems that have been sold. Another new system is the Omeo Senso. Again, so if you want to go along the rehab continuum, maybe a rehab robot like an Omeo Power or Hocoma can be afforded by a big rehab center like the St. Martin's Clinic. But if you go into outpatient therapy, then the budget is already smaller, space is already smaller, but the patients are already better as well. So you maybe need a system like an Omeo Spring, but ideally the patient can finish his rehab at home, and then you need a very simple technology. Sensors, maybe a simple bodyweight support system like the Saebo Mouse Mini, and just a game that you can play on your computer, and that's what we developed with the Omeo Senso, and I think that is the vision we have to develop products that go along the whole rehab continuum and allow us to optimally do the therapy of the patient. Not only in inpatient, that's a very important phase because we know we have to start early with movement therapy, but we have to keep doing the therapy until the patient has an optimal result. We talked about hardware. Ideally, the software does the same. Ideally, the software also follows us. That is why we are working on what we call the Hocoma. That's the Industrial Revolution 4.0 in the rehab that we also want to start. What does that entail? And on one side, of course, connecting the different devices in one clinic, but that's an obvious and simple thing. The more important point is to connect the different phases of rehab. So if we could connect the devices in the inpatient with the devices in the outpatient and in the home environment, that is when we can provide the data for the patients, for the therapists, when we can give the games and the scores and all the settings of one patient when he moves from inpatient to outpatient with him, and maybe even give the therapist with him. Because maybe even the therapist can still give the advice to the patient while he's in the outpatient and in the home environment. And there's many, many different options that you can do if you have a cloud-based system where everyone can access the data of the patient. And that's what we plan right now with Hocoma. But another thing is, of course, that we would have a huge potential for research. Why research? Because then we can collect data from many, many different systems. Imagine if you could collect data from 1,000 Omeo springs around the world. That would give us big opportunities. Now you could ask, is research still needed? Because there's, and the slide hasn't been updated for the last half year, but already at the beginning of this year, we had more than 400 peer-reviewed journal articles on the Locomat alone. So do we still need research? Yes, we do still need research, even though there's good Cochrane reviews, meta-analysis that shows that patients that train with electromechanically assisted gait training, that's how they call these devices like the Locomat, it's clearly shown that more patients get independent in walking with these devices. But still, on the other side, there are publications or even recommendations for clinical practice guidelines that have been published just this year, where it says clinicians should not perform walking interventions with robotics to improve walking, and with a strong evidence, actually. And I think that's why it is very important that we keep doing the very detailed and systematic research. And what Alberto Eskenazi did, he's the chairman of our scientific advisory board, is put all these different articles in the right context, because every study is being done in one particular patient group. And then if you look at what patients have been trained in each study, then you actually get a very more differentiated picture. You see here on the left, upper left side, those are all studies that have been done in acute phase with non-ambulatory patients. And what a surprise, these patients improve a lot, they profit a lot, highly significant outcomes. But on the right bottom, you see studies that have been performed in chronic and already ambulatory. Poorly ambulatory, but ambulatory patients, and there you see the evidence is not very strong. And that's not a surprise, because there is no tool, no magic pill that fits to all the patients, right? It's always, and that's very important, that we learn the right tool applied in the right way, in the right patient, that will give us the success. And I think that's why a lot of research is still needed, absolutely. But we have to be, on one side, go away from this 10 patients with and 10 patients without a certain approach. We have to go to bigger studies, and also intensive therapy is not 20 hours, right? I can tell you a secret. Roger Federer did not learn to play tennis in 20 hours. He needed much more than that. And I think that's the same in rehab. We have to get more intensive. And we need the clinical implementation studies that really look at these details, which patients profit from which approach. There is no one-size-fits-all. And that's where I think the big data can make the difference. But we need consortiums, and that's why I'm also happy to hear that St. Martin's is trying to bring together people, because big studies in neuro rehab can only be done by multi-center trials. And now the technology allows us to do that much easier. I mean, the conclusion on intensive therapy, I hope that is pretty clear. We can make a big difference if we train, but it has to be very intensive. And huge effects can be achieved even after many years. And I'll show you one example in a minute. New technologies will be able to enhance these results, and the future developments of new technology is going to be very important. I mean, we've been 20 years into this robotic revolution, but we still have done only a small step, and I'm very excited to see what's going on. But the dissemination of both the technology and even more the knowledge on how to apply it in the right way still needs to be improved. And I said I will show you another example. This is Rashida. Rashida had a paraplegia due to a meningococcal meningitis, and that was in 2012. And on the left side, you see her 2 years after the incident. She was still her movement were still very poor, and then she got trained very intensively over a long period, again in the Ambulanticum, so of this clinic from Dr. Bernd Kral. And you see her on the right side, how she is much more mobile. And I think that is also important, that this is also a key on how we can, of course, change many, many lives, which, of course, is our vision, but how we can also save a lot of money. Because imagine if Bernd Kral would have ended up in this nursing home for 12 years. That would have cost many locomats. Or if Nele would, for the rest of her life, stay in a wheelchair, rather than being at least a functional walker. And I think that is the big potential that we have. Now you maybe ask the question, why does not every rehab center in the world work like that? And unfortunately, we know healthcare system is a very complex machine, and it's not so easy because the St. Martin's Clinic cannot offer half a year of intensive therapy if there is no reimbursement. And so this whole complex machine of the healthcare system has to be changed. That needs a lot of work from a lot of different people. So behavioral change is needed. We need to educate all the people. It starts already in physical therapy school, where slowly these new approaches and new technologies are started to be taught. We need new business models for rehabilitation. We need to build up models for these intensive and efficient rehabilitation. And we also have to change the mindset of the patients, that they learn that they, even though we have machines, right? The first reflex of patients might be, well, there's now a machine, so I have to do less. But we all know it's the other way around, and that's what we try to do with the augmented performance feedback. We have to teach the patient to train more, be more active, and because it's, in the end, only the patient who can make the difference. And because this dissemination and this exchange is so important, that's why I'm also very happy that people are organizing conferences like this, advancing in movement. That's what we try to do. That's what I think the people that are here today are trying to do. And I congratulate the organizers for organizing this meeting. And also to the great clinic. I was able to see it yesterday. Wow, this is really a state-of-the-art rehab center. And I thank you very much for having me here. And I hope that in the next few years we will move on, advancing the movement so that we can help more patients like Nele, that they learn to get better, much better, and maybe even have fun while they are doing it. Thank you very much for your attention.